Welcome to the material session of Bhopal Sir's Career Point. This is a video on Unit 3 for the student of class 12. The name of the unit is Chemical Kinetics. It is strictly as per the new syllabus of Council of Higher Secondary Education Odisha and CBSE. This is the part 10 video of this unit covering the topics zero order reaction and its kinetics. आमे पूर्व जीरो डायरेक्शन कथा पढ़ीचु सीएचएस रे बहुत समय लॉन्ग क्वेश्चन हिसाब से आसी थाए हमको जीरो डायरेक्शन और तार काइनेटिक्स एंड इक्वेशन फॉर इट्स सप्लाई पीरियड डेराइव करिया को पड़ी थाए एबे हमें जीवा बिफोर गोइंग टू काइनेटिक्स वी मस्ट हैव टू नो व्हाट इज ए जीरो ऑर्डर रिएक्शन वी हैव टू राइट डाउन द डेफिनेशन फॉर जीरो ऑर्डर रिएक्शन द रिएक्शन हुज रेट इज इंडिपेंडेंट ऑफ कंसंट्रेशन ऑफ रिएक्टेंट्स is called zero order reaction. जो chemical reaction रेट टी concentration of reactant ऊपर डिपेंड करे नाही हमें ताको zero order reaction बोली कही था. Example, decomposition of ammonia in the presence of nickel or platinum 2NH2 and 2NH2. Ammonia रो decomposition to nitrogen and hydrogen एठी ammonia रो concentration ऊपर rate of reaction depend करे नहीं. The photochemical reaction are of zero order reaction. Suppose H2 plus Cl2 in the presence of diffuse sunlight or HMU gives us 2HCl. Here the rate is also independent on the concentration of H2 and Cl2. Any one of the example we have to write. Now come for the derivation of the equation for rate constant of zero order reaction. Let us consider a reaction A gives us product. Let A0 be the concentration of reactants at time t is equal to 0 and A be the concentration of reactant at time t and K0 be the rate constant of the reaction. According to law of mass action, rate is proportional to concentration of A to the power 0 implies rate is equal to K0 into concentration of A to the power 0, something to the power 0 is equal to 1. So we can write down rate is equal to K0. Let it be equation 1. According to rate equation, rate is equal to minus dA by dt. From equation 1 and 2, we can write down minus dA by dt is equal to K0. Now, rearranging this equation, we can write down minus dA is equal to K0 dt. Let it be equation number 3. By integrating equation 3, on integration both sides of equation 3 we get integration of minus dA is equal to K0 into integration of dt. At K0 is constant, see integration बाहर को जीवो. The integration of dA is A, implies minus A is equal to K0 t plus C, where C is the integration constant. Now when t is equal to 0, then concentration of A is equal to A0. आमे एटा को आगरू लेटर नहीं थिलु इते टाइम 0 से concentration of A को आमे A0 बोली नबा ए वैल्यू को जतरो इक्वेशन IV रे पुट करिवो what happens by putting these values in equation IV we get C is equal to minus A0. कारण t रो वैल्यू जते 0 हबो K0 t 0 हो जिवो आउ ए जगह में A0 नहीं थिबो so C is equal to minus A0 हबो. Putting the value of C in equation 4 we get minus A is equal to K0 t minus A0 implies K0 t is equal to A0 minus A implies K0 is equal to A0 minus A by t. This is the equation for rate constant of zero order reaction. Unit of K0. हमारा K0 is equal to हमें कौन जान लो A0 minus A by T. So पर एक concentration unit by time means moles per liter per second. Unit of K0 will be moles per liter per second. एबे जीवा हमें derivation of half life period. Half life period for zero order reaction. What do you mean by half life period? It is defined as the time taken to reduce the initial concentration of the reactants to half of its initial value. Half life period होचे सही समय जो समय भितर reactants concentration initial value अधा होता है. It is denoted or represented by the symbol T half or T 0.5. If the initial concentration is A0 when T is equal to 0, then a T is equal to T half, A is equal to A0 by 2. Because by definition we know that T half is the time by which initial concentration becomes halves. So A is equal to A0 by 2. Putting these values in equation 5, we get K0 is equal to A0 minus A0 by 2 by T half. That is equal to A0 by 2 T half. Implies T half is equal to A0 by twice of T0. Thus, the apply period for zero order reaction is directly proportional to the initial concentration. Thanks for watching Bhopal Sir's Career Point. Don't hesitate to ask your doubt in comment section. I must respond to this.